Hi, today we're going to be solving trigonometric equations. For example, in number 1, we want to solve the following for all values of theta in the interval 0 degrees less than or equal to theta less than 360 degrees. So what that basically is saying is that they want you to find all the angles from 0 to 360 that work in that equation. 2 cosine theta minus 1 equals 0. And in order to do that, we're going to actually solve the equation to get the function first by itself. And you do that like you would do any normal solving in the past. So let me highlight. So first we're going to get the trig function by itself. So we're going to get cosine theta by itself. Now in order to do that, we have to get rid of the 2 and we have to get rid of the subtract 1. Well, to get rid of, now we do the PEMDAS in backwards order. So first we're going to add over the 1. And you'll have 2 cosine theta equals 1. And again, I want you to keep in mind, we're trying to first get that function by itself. There it is. And now we're going to divide out the 2. And we get cosine theta equals a half. Now, just as an aside, we're not done yet, but just as an aside, if you wanted to, you could have changed the cosine to an x and solved it with an x first. And that makes it look less distracting. And notice, there it is right there. And then you can substitute cosine back, because we're not done yet. Our goal is to find the angle now that makes cosine of that angle equal a half. And this shouldn't be too new to you. I keep on telling you that if you want to find the angle itself, you do inverse. So first we're going to do cosine inverse of a half. Now if they don't tell you to round, you really should expect nice answers. Otherwise they would hint that there's rounding that's going to occur. So cosine inverse of a half. And also this value should kind of seem familiar because it's one of our special values. And you get 60. Okay, but then we're not done, because you have to always keep in mind that the angles have 2 places where they're positive quadrants and 2 places where they're negative quadrants. So you're going to figure out the angle by doing the inverse functions. And then you have to use the ASTC to determine which quadrants you're in. And then from there determine what the angles are. Okay, so ASTC, we have a positive value for cosine. Cosine is positive in 2 quadrants. It's positive in the all quadrant, and it's also positive in the cosine quadrant. Now that 60 is going to be the angle in both of those quadrants. So in quadrant 1, the answer is 60. That's the only time the angle actually matches itself. And then in quadrant 4, you have to remember it's 360 minus 60, which is 300. And those are the 2 angles that will make cosine theta equal 1/2, positive 1/2. Okay, another things to keep in mind I have in the gray boxes, that you will always have 2 answers for theta, because there's 2 quadrants where they're positive and 2 quadrants where they're negative. There's only 2 exceptions though. One, anytime sine or cosine equal 1 or negative 1, you're only going to have 1 answer for the ones on sine and cosine only. And then number 2, remember sine is the y value and cosine is the x value in a unit circle. So sine and cosine have to be less than or equal to 1 or greater than negative 1. So if you get a value for sine or cosine that's more than 1 or less than negative 1, it means that it's going to be out of the domain. So it'll be a reject. Okay, example number 2. Solve the following for all values of theta in the interval 0 to 360 again. All right, so first we're going to get that function by itself. If it helps you to write it just with a plain x and solve it like that, I'll show you how that works. You subtract over the 2. And don't get all confused with that radical. Radical 2 is just a normal number. It's in front of the x by multiply. So if I want to get rid of it, I have to do the opposite inverse operation. It's radical 2, or divided over. And then we get x equals that. And if you want to do it with the x's, what happens now over here is you just solve for that thing I underlined. So you now know that cosecant theta equals negative 2 over radical 2. Now at this point, you guys within Inspire, you do in fact have a cosecant inverse key. You may do that at this point. With the 84 calculator, you don't have a cosecant inverse. So we need to change this to its other function. And remember, cosecant is sine flipped. So then we're going to change to sine. And we can change it to sine because we know that sine is the reciprocal value. So we're just going to flip that. And now I can do what I did in problem number 1. Once I get the function by itself, now all I have to do is figure out the reference angle, figure out what quadrants they're all good in, and then I can find the rest of my angles. Now, since this doesn't equal 1, I know I'm going to have 2 answers. Sorry. Okay. All right, so finding my angle, I'm going to first do sine inverse. Of radical 2 over 2. Okay, notice I took off the negative. The negative just tells you what quadrant you're in. You really want to know what the reference angle is. So taking off the negative is going to be to your advantage. So first we're going to do sine inverse of radical 2 over 2, and we get 45. Okay, so now making up our ASTC chart. I want to know where is sine negative. So it's not in the first because sine is positive, and it's not in the second because S means sine is positive. So sine is negative in the third and in the fourth quadrant. So that 45 is that angle that I needed to put here and here to help me figure out my true answers. So in this quadrant, we're going to do 180 plus 45, which is 225. And in quadrant 3, we're going to do 360 minus 45, which is 315. So those are my answers. Theta is equal to 225 and 315. All right, going on to problem 3. Okay, so again, I'm going to try to get my tangent theta function by itself, and I'll highlight it. Now this time we have a tangent theta term on both sides of the equations. So I don't have to change it, but I know a lot of you guys will probably want to change those to x's because it makes it just less confusing and congested looking. So the first goal is really this. I just replaced the yellow tangents with an x. That looks much more familiar. So my goal is to get that tangent theta by itself. And I used x in its place, so now I can just solve for x. Okay, so now I know my goal is really to get tan theta to equal -1/3. Now, you don't have to change it to x. I know, but again, most of you guys are going to prefer that. If you want to see what it's going to look like if I hadn't changed it to x's, you would have had to have known to do this. All right, so you can do it with x's or you can do it without x's. If you do it with the x's, though, after you do this x step, you do, in fact, have to change that to tan theta equals -1/3, because you had just replaced it with an x just for your benefit, but that wasn't the real problem. So you can either do the left side or the right side, whichever you prefer. Now, I need some space, so I am going to erase the right-hand side with x's so I can finish off the problem. Okay, so at this point, we got the function by itself. That was step 1. And now step 2 is to find the angle. Now, I didn't read the directions on this one. It says solve the following for all values of theta to the nearest degree. Now, if it tells you to round, that means you know that this isn't going to be one of your special angles, and you are, in fact, going to get an ugly answer that you have to round. All right, so now that we know what the tan equals, we're going to do tan inverse. And remember, +1/3. I don't care about the negative right now. I need to know what that reference angle is. Okay, so tan inverse, and I will expect a not pretty answer because of that rounding issue. So I get 18.4 degrees, so that's 18 degrees. All right, making my ASTC. I'm going to erase that again. All right, making my ASTC. I should have made them higher to get my room for my reference angle. All right, so now I have to know, where is tangent negative? Well, tangent is not negative in 1. It's all positive there. Tangent, it would be negative in the S because sine is positive. Tangent would not be negative here because tan is positive. And tan would be positive in the cosine one because that means cosine is positive. Remember, the 18 goes in the pocket because you make your triangle like that. 18 goes in the pocket. And I just have to find the angles where that would work. So in quadrant 2, it would be 180 minus 18. And you get 162. And in quadrant 4, it would be 360 minus 18. And that would be 342. So your answers are theta equals 162 and 342 degrees. All right, problem number 4. Solve the following for all values of theta in the interval 0 to 360. No rounding, so I probably should get our nice answers. And if you notice this one, we have a cosine squared. That means that this is actually a quadratic equation, our old friend, the quadratic. This is definitely a problem that you probably will want to actually replace with x's to make it a little bit easier to see how to factor, because yes, quadratics, you're going to factor to solve. And if you don't want to factor to solve, you actually can use the quadratic formula. And remember, the numbers in front, and I'm not going to do it that way, but the numbers in front are your A, B's, and C's. A is 1, B is 3, and C is 2. So if you want to do it by the quadratic, that's great. The thing is the x is not going to be x, obviously. Whatever the function is, that's what would go there. So, for instance, in our problem, we're doing cosine. So when you plug your numbers A, B, and C in for that formula, it would actually give you the cosine value is equal to that. And then we're going to do inverse to get the angle itself. So that's how you would use the quadratic formula. Some of you guys might like that because then you don't have to factor. So this problem here, I will do it first by factoring, and then maybe after that I'll erase it just to show you how the quadratic formula would have worked. So you may want to factor or change those to x's. And now we have to factor, and this is our easy factoring. It's going to be x and x. There's a multiply to 2 and add up to 3. So x plus 2, x plus 1. All right, so setting both equal to 0, you get x is negative 2 and x is negative 1. All right, now if you recall, I told you on the front page that sine and cosine cannot go beyond a unit circle of 1. So this should make sense that this is going to be a reject. Now, if you don't remember that, you can try to do cosine inverse of negative 2 or 2. And you're going to get an error domain problem because it means it's going beyond the value of what it can be. So that means that's a reject. Now again, the ones are really special ones. Ones and zeros for cosine and sine means it's one of our quadrantal angles. Let me just show you this. Some of you guys may actually prefer to do the ones and the zeros this way. This is the point 1 over 0 up. This is the point 0 over and 1 up. This is the point, and remember, this is on a unit circle. This is the point negative 1 over 0 up, and this is the point 0 over negative 1 down. Now, if I label this with x is cosine, y is sine, and I go over, anytime you have zeros or negative ones or ones for cosine or sine, you may actually want to do it this way. So where is x, which is in our problem, x is cosine. So basically I'm trying to solve where is cosine negative 1. So if I draw my little unit circle, I just got to find out where is c negative 1. And c is negative 1 right there. And this angle is 180 degrees. This is the only time that you wouldn't take off the negatives. Anytime cosine and sine hit 0 or negative 1, you actually want to leave the negative because we're not talking about reference angles. Every other angle has a reference angle but the ones and the negative ones and the zeros. So that would be how you get your 180. Now, if you do cosine inverse of 0, you're going to get one answer. I'll just show you. But there is another answer. Cosine is 0 at 90 degrees, but also cosine is 0 at 180. So you have to be careful about the zeros, the ones, and the negative ones. I like the unit circle method because you can see all your answers. If you do the inverse method, you have to know that 0 has 2 answers, but the ones don't. And don't take off the negative on the negative 1 for cosine. Now, if you did Pythagorean theorem, I said I would show you that. If you did Pythagorean theorem, it would work. You would actually get negative 2 and negative 1 as answers. So let me show you what that would look like. So we're done with the problem. The answer is only negative 180. But just for the sake of showing you that it would work for the Pythagorean theorem, so it would be negative b would be negative 3 plus or minus the square root, and 3 squared is 9, minus 4 times 1 times 2 for c, all over 2 for 2 times 1. You're always going to do under the radical first. And if you do 9 minus 4 times 1 times 2 in your calculator, you'll get a 1, which square root of 1 is 1. And then you get negative 3 plus 1 over 2. And that's going to give you negative 1. And then you're going to get negative 3 minus 1 over 2, which is negative 2. So those are the exact two answers we got there. Then the same thing would have happened. You would have had to have rejected this one because cosine doesn't equal that. And then you would have to have solved for this, which we get the same answer. All right, so it's up to you how you want to do it, but my suggestion is a lot of you guys are going to probably prefer changing them to x's and solving like normal, and then at the end you replace back cosine or whatever the function is. All right, we'll try 2 more problems. All right, problem 5 says solve the following for all values of theta to the nearest degree. That means we know we're not going to get our nice special angles. And on this problem, you have to be careful because we have a cosine of 2 theta. That's not the same as cosine theta. So those 2 functions are not the same. Even though they both say cosine, they're not cosine of the same angle, and that's not good. So we have to recall, anytime you see a double angle, you probably want to look at your formula card, and I have them at the bottom. Cosine of 2 theta, you have 3 formulas. And in order to help us figure out which one to use, we have to look over here. The other part of the equation has just a single cosine. So I wouldn't want to use number 1 because that involves 2 functions. And I wouldn't want to use the last one because that would also give me sine squared, which is not the other function. So this is my best choice to use. So what we do is we're going to replace this guy right here with that formula right here. All right, now we still have that 3 on the outside, so I'll leave that 3 on the outside. We're going to replace the formula in there, and we still have the rest of the equation. So that 2 cosine squared theta minus 1 is what I'm replacing for cosine of 2 theta. So we're just substituting an equal for an equal. Now at this point, you may now want to change it to x's. So cosine and cosine theta are both the same function. So now you can use an x. That might be to your advantage. So I'm going to do it by replacing it with x's. And solving it like normal. So distributing. Combine like terms. This guy and that guy are like terms. All right, and at this point, we can either do the quadratic formula or we can factor. Now, it says to the nearest degree, so sometimes that scares me when it's one of these because it's possible that at this point it can't factor and I have to use the quadratic formula. But let's try factoring first. You would do the AC method like normal. I'm going to do it by the guess and check method. So 3x times 2x is 6x squared. 3x times 1 is 3x, and negative 1 times 2 is negative 2x, and it adds up to 1x, and negative 1 times 1 is negative 1. So that actually checks out if I were to FOIL it or double distribute it out. So that does in fact factor, but if you could do the AC method, like I said, or quadratic formula. Okay, keep in mind, this was just finding out what the function was. So now I have to put cosine back in. All right, this is cosine, and they're both below 1, so that means that's good. It means it's going to have answers. And there are going to be 2 answers for the cosine theta is 1/3, and there'll be 2 answers for cosine theta is negative 1/2. All right, so doing my ASTC chart, I have to actually do it for both of them. Cosine inverse of 1/3. All right, I get, remember, rounded 71 degrees. All right, so where is cosine positive? Cosine is positive in quadrant 1 and quadrant 4. So I'm going to put that 71 here, and I'm going to put that 71 there. So one of my answers will in fact be 71 degrees. That was quadrant 1. And now I have to figure out this one, which would be 360 minus 71. I'm going to subtract that. And 289 would be the other answer. Okay, now I'm also missing the other answer. I have to do cosine inverse of negative a half. Okay, so remember, I'm going to do cosine inverse of positive a half. And I get 60. So, okay, that one came out to be a good value, which I like. So I'm going to go ahead and make my chart. But this time, I need it to be a negative 1/2. So cosine is negative, not here and not here. Those are positive. So cosine is negative here and here. I put my 60 in my pocket. And my answer is going to be in here. It's going to be 120 degrees for 180, take away 60. And in here, it's going to be 180 plus 60, which is 240. Okay, so adding that to my answers, I have 4 answers now for this problem. And it's okay if they're out of numerical order. The answers don't have to be in numerical order. Okay, one last one. This one here. Solve the following for all values of theta in the interval 0 to 360. So no rounding involved. Probably going to get one of my special right angles. Notice I have a sine squared and a cosine theta. Not the same function. So if you recall, we can change sine squared to something involving cosine from our identity. Down below, if you remember, this is the main identity. I don't have it written, but we know that identity, sine squared theta plus cosine squared theta equals 1. And recall that that formula, I can subtract over cosine squared to get to that, and I can subtract over sine squared to get to that. So keep in mind that other identity. So I need these to both be the same. So I want to replace, in this formula, I want to replace sine squared with 1 minus cosine squared. So I still have the 2. 1 minus cosine squared theta plus 3 cosine theta equals 0. They both have now a cosine theta, so I can use that whole x substitution method. And then I can solve this like normal, distributing. Okay, combine like terms, but there are none. I really want to get this x squared guy to be positive. So I'm going to add him over, subtract him over, and subtract him over. Okay, you can factor this or do the quadratic formula. It is factorable if it doesn't talk about rounding. That's a given. So let's see. I'm going to do this by the guess and check method again. Okay, so that actually, if you were to check it, will in fact give you this. So that is correct factoring. Okay, I'm running out of room. So this will be negative a half for x, and the other side would be 2. Now, because this is sine, no, I'm sorry, we replaced x with cosine. This is actually cosine theta equals 2, and this is cosine theta equals a half, negative a half. Cosine and sine cannot go beyond 1, so this is going to be a reject. So don't need to do that side. And remember, tangent can go above 1, so please don't reject tangent. That rule is only for cosine and sine. So all I have to do now is just this one side. So cosine inverse of a half. If you put that in your calculator, I believe it should be 60, but we'll do it again. That's one of our special ones. So it's 60. So then I'm going to make my ASTC chart. And I need to know, though, where it is a negative a half. So it's going to be negative value for cosine, not here and not here. So negative 60 here, and then it's going to be negative in there. So in the second quadrant, that's going to be 180 minus 60, which is 120 degrees. And I'll put the answer up here. That was quadrant number 2. And quadrant number 3 is going to be 180 plus 60, which is 240.